Lesson part 3, growth and decay. So these functions are used a lot for when things are growing very quickly or decreasing very quickly. Now remember, this is our function. Now it really doesn't matter what a is for the growth or decay. What matters is the b. So here's the basic rule. If the common ratio is bigger than the number 1, it will grow. Now, it can grow slowly or it can grow a lot quicker, but the bigger the number, the faster it'll grow. Now, for it to grow smaller, you don't use negatives. No, you use decimals or fractions. So numbers that are between 0 and 1. Numbers that are between 0 and 1 will make the graph go down and decay, okay? So the b is what's really important. Now, in the real world, you're going to usually see percentages for this number. So we're talking about percentages are always out of 100, but the rate at which it grows will change. So if you're going to grow, you're going to add the rate to 100. But if you decrease it, you're going to subtract the rate from 100. And this is how you determine your multiplier. You take the percentage at which it's going to change and you apply that to 100, and then you'll know what kind of function it will be. So for these problems, I'm not going to use function. I'm going to use the equation format. I'm going to use y equals a times b to the x, where a is going to be the initial amount and b is our increase or decrease amount. It's our multiplier, okay? But is going to be based off this, increase or decrease. So you have to decide which one you're using, okay? So your formulas can either look like this. Sorry, let me try that again. Your formula could be either one that is growing, or it can be one that is decaying. Okay, so we're going to do a couple examples of how to apply it with the percent changes. Okay, so x is going to be the number that goes at the end, and that's how long is a time change for this word problem. Okay, so we're going to do two examples to kind of go through this exactly to show you what it looks like. Okay, so let's use this. Hand sanitizer was appreciating. Now appreciating, this word means growing in value. Okay, so it's appreciating in value 10% each month. So 10% each month. If you bought a big bottle for $8 in January, how much could you sell it for now in June? Okay, so before I write my formula, I'm going to start with the percentage, 10%. Now, it's not 10% in my formula. No, no, no. It has to affect the 100%. So am I going to add it to 100 or subtract it? And it depends on what it said. It is appreciating in value, means it's going to grow in value. Okay, so your B is going to become 100% plus 10%. And that's going to be 110%. Okay, now if you're going to use a calculator, you also have to do one more thing. If your calculator doesn't have a percent button, you have to change this to a decimal. Okay, now the way you change a percent into a decimal is you take where the percent symbol would be, there's a decimal point here, you move it 2 times, okay? And that would make it 1.10, okay? So why am I doing that? Because if you treat this like a fraction, okay? If you treat it like a fraction, 100% is complete. That's your total. So 100 out of 100 would be 1, okay? If you just have a 1, it won't change anything. No, no, no. Remember how I told you the multiplier has to be bigger than 1? So if you take 110 and divide it by 100, you're going to get 1.1. What you're doing is you're basically saying, how is it changing from 100? It's growing. It's going to be bigger than 100. So the multiplier is going to be 1.10 or 1.1. It's up to you. Okay? So we're going to go. Now I'm going to write my formula. Y equals A. How much did you pay for it? $8 at the beginning. What is our multiplier? 1.10 or 1.1, up to you. X. Now, X is your time frame. Your time frame was every month. For how many months though? Because I'm not just going to plug in one. How many months is it from January to June? So you count. Okay, so you got February, March, April, May, June. So it's 5 months. So it's 5 times that the value has grown. Now in the real world, nobody would do this because that would be called price gouging. And I think it's actually illegal. You can't sell things for crazy amounts, especially things that are necessary. But you go to your calculator, right? And you're going to multiply 8 times 1.1 to the 10 power. So let me put this in my calculator. 1.1, sorry, not to the 10, to the 5th power. And then multiply that by 8. So your calculator is going to be very useful here. The new price for that will be now $12.88. So you get about $5 profit on this. Okay, so this is basically what you're doing. You're using A times B, okay, to the X power. We're still using this, but your B is a lot more difficult to understand. A doesn't change, that's your starting amount, but B is now a percentage, and you have to use that percentage to either grow it from 100 if it's going to increase, or you subtract it from 100 if it's going to decrease. Okay, now let's do one where it decreases. Cars depreciate. So a new car at $15,000 will lose 12% of its value every year. So that's important information. Depreciating is losing value. So you'll start with this price, but you'll lose this price every year. How much will it be worth in 5 years? Okay, same thing. Before I write my equation, I have to figure out the B. So you're starting with 100%. The car starts at full price, but it's going to lose value. How much will it lose? 12%. So this is going to be your new B. 100 minus 12, that is going to be 88%. And again, if you don't have a percent in your calculator, turn that into a decimal. You move the decimal point twice, so you take 88%, move that decimal point twice, you get 0.88. Now, your equation. $15,000 times 0.88 for how long? Once a year for how long? For 5 years. So 5. Again, we're going to go to our calculator and we're going to solve this. So if you have your cell phone calculator, you actually want to start backwards. You want to start with this. So you go with 0.88, this key right here, to the 5th power. And you're going to multiply that by your A times 15,000. The new price of the car, if you sell it in 5 years, $7,915.98. So like almost half. And this is what really happens to cars. Now, of course, this is very simplified. This is just age. Of course, there's other things that could drop the price of a car or increase the price of a car. But this is basically appreciation and depreciation, growing value or decaying in value.